Additive manufacturing was created in 1994. It is often compared to 3D printing with metal as raw material. It allows to overcome some weaknesses of the modern industry, in particular the production of bespoke parts that could be very useful in aeronautics to push their performance to the maximum. It makes possible to obtain parts with a great geometric complexity and with a low production time. This process is booming in particular in the field of aeronautics, which is trying to develop it quickly in order to make it a major asset for the design and the manufacture of complex parts used in the assembly of reactors and fuselage.
The selective laser melting process allowed the production of metal parts from a laser and alloy powder, such as steel, nickel, and aluminum alloy, created by atomization. In the aerospace industry, SLM is widely used to manufacture parts with complex geometry that are difficult to manage. For example, SLM has been used to produce fuel injectors for Arano engines used on helicopters such as the H-160. Thanks to this process, it has been possible to go from an assembly of 12 parts to one-piece system containing shapes that were previously uneditable using conventional processes. But how does it work? SLM is a manufacturing process based on the principle of adding material via selective laser melting. Specifically, this laser fuses layer by layer of metal powder to each other in response to a digital model. To explain very precisely how this machine works, it is important to understand the principle explained just before. The 3D printer fills its chambers with an inert gas and then heats it to the optimum temperature. A first layer is applied. The laser beam between 200 and 400 watts will solidify the powder by fusion. The plate goes down one floor and little by little a ricotta will come and put layer that will be refused by the laser of the previous one to finally form the required part.
Wire arc additive manufacturing technology. So there are many processes for metal additive manufacturing. Unlike SLM, which requires powders and laser, WAAM technology used an electronic arc to melt a metal wire. This technique, which is similar to welding and can be used to produce parts made of titanium and aluminum. When manufacturing components with the WAAM process, the stability of the welding process used and the heat dissipation are decisive criteria. The soldering process must be as energy efficient as possible so that the lower layers don't melt a second time. For example, the French company Stelia Aerospace used WAAM to create a disruptive design for fuselage panels. The aluminum stiffeners are directly integrated into the panels by additive manufacturing without the need for welding or assembly.
Weight issues are crucial in aeronautics. Because the heavier an aircraft is, the more power it requires to fly and the higher its fuel consumption. Structures are therefore lightened as much as possible, and additive manufacturing makes it possible to design optimized seats and components. Sometimes up to 50% lighter and using minimal quantities of materials. Metal additive manufacturing is now being used to design the brackets for the GNX 2B engines. Additive manufacturing makes it possible to produce cobalt chromium alloy parts that are 10% lighter and to reduce metal waste by 90%. This reduction is the amount of material used in the strategic issue, as the industry is frequently exposed to the risk of metal scarcity. Other manufacturers are turning to additive manufacturing technologies to replace CNC for rapid prototyping. This allows them to develop working prototypes in as little as 2 days, which represents 55% reduction in lead time and 40% cost savings.
Thank you for listening. It was Arnaud Fournel and Hugo Demorey into this presentation.